Amelogenin is the name for a series of closely related proteins involved in amelogenesis, the development of enamel. They are a type of extracellular matrix, ECM, protein, which, together with ameloblastins, enamelins, and tuftelins direct the mineralization of enamel to form a highly organized matrix of rods, interrod crystal, and protein. Although the precise role of amelogenin, S, in regulating the mineralization process is unknown, it is known that amelogenins are abundant during amelogenesis. Developing human enamel contains about 70% protein, 90% of which are amelogenins. Function: amelogenins are believed to be involved in the organizing of enamel rods during tooth development. The latest research indicates that these proteins regulate the initiation and growth of hydroxyapatite crystals during the mineralization of enamel. In addition, amelogenins appear to aid in the development of cementum by directing cement oblasts to the tooth's root surface. Variants: the amelogenin gene has been most widely studied in humans, where it is a single copy gene, located on the X and Y chromosomes at XP22.1, XP22.3 and YP11.2. The amelogenin gene's location on sex chromosomes has implications for variability both between the X chromosome form, Amelx, and the Y chromosome form, Ameli, and between alleles of Ameli among different populations. This is because Ameli exists in the non-recombining region of chromosome Y, effectively isolating it from normal selection pressures. Other sources of amelogenin variation arise from the various isoforms of Amelx obtained from alternative splicing of mRNA transcripts. Specific roles for isoforms have yet to be established. Among other organisms, amelogenin is well conserved among eutherians, and has homologs in monotremes, reptiles, and amphibians. Application in sex determination. Differences between the X chromosome and Y chromosome versions of the amelogenin gene, Amelx and Ameli respectively, enable it to be used in sex determination of unknown human samples. Amelx's intron 1 contains a 6BP deletion relative to intron 1 of Ameli. This can be detected at low cost using polymerase chain reaction, PCR, of intron 1, followed by gel electrophoresis. Two bands of DNA, at 106 bps and 112 bps, are resolved if both the Amelx and Ameli versions of the gene are present, i.e. the sample is from a male, or one band of DNA, at 106 bps, if the Amelx version only is present, i.e. the sample is from a female. However, because of Ameli variation among individuals and populations, this method of sex determination is not 100% accurate. Mutation in regions of Ameli intron 1 commonly used as primer annealing sites may disable PCR amplification. A 6BP insertion to Ameli intron 1 results in an AMPL icon identical in length to that of Amelx. In some males, Ameli may be deleted entirely. In any of these cases, only one band is visualized during gel electrophoresis of PCR products, causing misidentification of the sample as female. The misidentification rate may vary among populations, but in general appears to be low. In one study in Spain, the amelogenin sex determination test using Amelx, 977 bps, and Ameli, 790 bps, bands was performed for 1,224 individuals of known gender with a 99.84%, 1222/1224, accuracy rate. Another study in India, however, found 5 of its 270 men studied, 1.85%, possessed an Ameli deletion, terming them deleted amelogenin males, DAMs. In response, the authors suggested that while the amelogenin sex test may be accurate in general, other Y chromosome markers such as SRY, STR, or 50F2 can be used for less ambiguous gender identification. Clinical significance. Mutations in Amelx can cause amelogenesis imperfecta, a disorder of tooth enamel development.
Please subscribe and thanks for watching.